We just talked about the rational zero theorem, so now we're going to talk about your factor theorem. This theorem is going to state that if you are checking for a polynomial that has a factor x minus k as a factor by evaluating the polynomial x equals k, this is kind of what I was talking about before. If your result is 0, then x minus k is an actual factor. So example 6 says we need to show that x plus 3 is a factor of x to the third plus negative 19x minus 30 equals 0. And in this case, it says right here, show that it is a factor. So that means it is an actual factor. So we're going to use the, algebraically, we're going to use the synthetic division. So if you have x plus 3 as a factor, that means you're going to plug in negative 3 into the box. And then you bring down your coefficients, and that's going to be a 1 for your x to the third. You don't have an x squared, so that means you need to plug a 0 placeholder in. You're going to have a negative 19 and negative 30. So bring down your 1 at the very beginning. Bring down the 1, and you have a 1 below your line. So then you have to multiply that by the negative 3. 1 times negative 3 gives you negative 3. So when you add those together, you get 0 minus 3 is negative 3. Plug a negative 3 in times negative 3. That's going to give you a 9. So when you add negative 19 and a positive 9, that's going to give you a negative 10. And, or sorry, and negative 10 times negative 3 is going to give you a positive 30, which when you add those down, that means your remainder is going to end up being 0. So if your remainder is 0, that means that x plus 3 is a factor. Now if you look at your depressed polynomial, you're going to have an x squared minus 3x minus 10. And what we have to find here at the very end is, it says find the remaining factors. So you just take your depressed polynomial and you can factor this a little bit further. So we need factors of negative 10 up to negative 3. That's going to be x minus 5 times x plus 2. And those are your remaining factors. So this would be your final answer. Do not set this equal to 0. Set each of these equal to 0 and find out, say x equals 5 and x equals negative 2. It's asking for the remaining factors, not the zeros. So just the factors, and then you should be good.